For this question, finding the mass of acid and its absolute uncertainty and its percentage uncertainty. So mass of acid is going to be, so you have to subtract these two numbers because that's bottle and bottle plus acid. So if you minus the bottle, you get just the acid. So 2.412 minus 1.73. So that's going to give you, okay, I'm keeping the 3dp. Okay, if we have to change, for now there's nothing to change because it's just asking you to get these three things independently. So then the absolute uncertainty in mass is going to be the sum of the two uncertainties. Okay, even if you're doing subtraction, you're always going to add uncertainties. So that's the absolute uncertainty, and the percentage uncertainty is going to be 0.02 divided by the value. That gives me 0.296%, which I round up to 1 SF, so 0.3%. So 1 SF here. Second part, this dissolved to form 100 centimeter cube. You have to find the molar mass of the acid. So molar mass, to get the molar mass, I'm going to use mass divided by the number of moles. So the mass, I already know it. This is what I have here, the mass. So it's the number of moles that I need to find. So I have the concentration of NaOH. I have the volume of NaOH. So I can get the number of moles of NaOH. Once I have the number of moles of NaOH, I have to know with how much acid it's going to react. Now, let's look at the question. It says a monoprotic acid. A monoprotic acid, you have acids like HCl, HNO3. These are monoprotic acids. Then you have diprotic acids. That's like H2SO4, sulfuric acid, carbonic acid. So monoprotic acid has only one hydrogen that is going to be liberated, so it produces only one H+. Diprotic will produce 2 H+. Triprotic will produce 3 H+. So for monoprotic acid means that when HA will react with NaOH, there's just going to be one H+ that is going to react with the OH minus, which means that the ratio of acid to alkali is going to be 1:1 because it's monoprotic. So you'll have NaA plus H2O. Just like you would have, let's say you'd have HCl plus NaOH, you'd have NaCl plus H2O. Okay, so it's the same thing. Monoprotic acid produces only 1 mole of H+, which means that it's going to react in a 1:1 ratio. So if I have the number of moles of NaOH, I get the number of moles of acid. Okay, so let's work it out now. So number of moles of NaOH, that's going to be concentration times volume. So I have the concentration, I have the volume here. Volume, this is in centimeter cube. I convert that to dm cube. Okay. So 1.21 times 10 to the power of minus 3. That's the number of moles of alkali, which means that in that 25 centimeter cube of sample, this 25 centimeter cube contained the same number of moles because it's 1:1 ratio. So then we can add here. So 25 centimeter cube of HA solution also contained this number of moles of the HA acid. Now this is in 25, so I can find in 100 centimeter cube of solution. So simple proportion divided by 25 times 100. So that gives me number of moles. Now I know that MR is mass divided by number of moles. The mass, I've already found that in the previous question. This is what I have here. And the number of moles, this is what I just found. So that gives me, so this is to free SF, okay. This also to free SF, because all the values here, this is free SF, so that would be free SF. So free SF here. So my answer to free SF gram per mole, this is to free SF. Okay, so that's the MR of the acid. Now you have the percentage composition. You'll have to find its empirical formula. It's very easy. Carbon, oxygen, and hydrogen. Divide by AR. Divide by the smallest. So that gives me 4, 1, and 4. So then empirical formula C4H4O1. We're not going to write the 1.